Voice of the Sea, learning from experts across the ocean.
Welcome to Voice of the Sea. In this episode,
we traveled to Guam. We met up with Terry Donaldson.
You know, I'm really fascinated by this idea of technology, and sometimes it's these really elaborate computer programs or a very expensive camera, but a lot of times in biology and ecology, technology just means you're taking everyday tools and using them in a scientific way. And so you have these GPS, which are not a particularly expensive GPS. People use these for everyday uses, but you've put it into a situation that allows you to collect really valuable information.
That's correct. This is off-the-shelf GPS unit. You get about $150. We used to get them cheaper, but you know how that works. Pat Cullen and I devised a simple way to tow them around with you. And you put them inside of a waterproof housing, like so. Seal them up. We used to use screws with O-rings. Now we just use these things with O-rings. Attach it to a simple reel that contains, I don't know, maybe 50, 60 meters of line. Counterweight, you've got a float, and you can use this, tow it behind you, maybe 2 meters behind the observer or the observer's assistant. And you can do it on the surface, or you can be down in 30 meters of water towing this thing above you. And you just use a little bit of scope to adjust for tension so you don't submerge it when you pull too hard. But also you can make adjustments if there's chop upstairs, you know, if it's a bit choppy, the water actually. And you get a fairly good idea of where you've been. And then you correlate that with the time that I mentioned earlier, that you can geo-reference the latitude, longitude with a particular time. Go back and you can map that, and you can predict where fishes are likely to aggregate, or you can actually show where they've been aggregating. You can calculate densities because you limit the distance you look to the left and right when you're doing your survey. And you can marry that data onto a bathymetric map that you may have made of the bottom using a side scan GPS referenced sonar. So you can look at the way the distribution of fishes relates to the underwater habitat. And then where you've got big densities of fishes, there's something about that habitat they like.
So people nowadays are really familiar with the use of GPS, and they come standard on all these smartphones and things like that. But underwater, you can't actually use a GPS, right? Right. And so without a system like this, it would be impossible to know exactly where you were.
Pretty much so. I mean, you can lay out, very painstakingly lay out a grid system. I mean, people were doing that before they could do this, and get a fair idea of where you are. But I can swim for several kilometers along a reef front with one of these things. No one's going to lay out a grid for several kilometers. Okay, so that's the utility of using this method. It allows you to get around an aggregation site, so you can calculate the area of the site. You can do abundance estimates. You know, you just follow a protocol. So many minutes or a minute, every minute you take a count, and you can get a subsample, and eventually you can get an idea about how many fish are at the spawning aggregation site at that given day or time that you're surveying it. There are all sorts of crazy things you can do. You don't even have to be limited to spawning aggregation sites for this. If you want to count the number of sharks on a reef, you're going to do a better job with this swimming long distances than you would be just standing still or just using traditional methods like transect tapes. We use underwater scooters with these things sometimes. Seriously.
What's an underwater scooter?
It's behind you, but it's essentially, you know, an electrically driven device that can pull a diver along. Now you can buy sport models, and they're nice, but they're not particularly useful because they're weak, and if you get into currents, they cause problems. So we use an industrial grade type of underwater scooter, and when we're diving or even snorkeling, we can survey large areas. And so if you're having to deal with a huge amount of area to survey in a relatively short period of time, the scooters are good for that. If you're dealing with current, in most cases the scooters are good for getting you through the current. so you don't get swept away or you don't wear yourself out. Sometimes they're actually also useful for popping, let's say, groupers out of habitat, because the noise of the scooter is just loud enough to disturb them a little. They're at a spawning aggregation site and you do an estimate, you may not be counting everybody who's there, in the daytime anyway. At night they'll be out, or sunset they'll be out. But if you go through an area like Oolong Channel I showed you earlier, using these scooters, if you make 4 or 5 passes in the channel, the length of the channel, you're actually scaring them out of cover, and they come out and look around to see what's what. And so it actually helps to improve your estimates. And again, you have a position using one of these. My colleague Pat Collin has actually surveyed most of the entire circumference of the island of Bali, counting humphead wrasses. And it took him a few days, obviously, to swim around this entire island, but he used one of these methods and worked out just fine. So for big fish, it's a great way to go. For fish that are really cryptic, like lionfishes, it's also or stonefishes or anything like that, it also has turned out to be more useful for making estimates, because you can cover a lot more area, and you can peek under things, and you're not worried about staying on a line necessarily.
Sure.
As you just limit the approximate width of what's in front of you, you can get much better data than you could from a simple transecting method. So.
I see that you have a camera there too.
Well, it's not as cool as some of the cameras I saw you using, but yeah, we just like to document behavior with video cameras. Also, we like to get shots of the habitat, and so we use, for today we weren't working out of a boat, so I took one of the light ones. If I'm working out of a boat, I've got a big heavy-duty number and a big heavy-duty housing, and it does everything but fly the space shuttle. It's actually quite good. And we just get these records. We also use still photography, again, little cameras if we're traveling light, better cameras, bigger cameras if we've got a boat to support our work. We're using these cameras that you were using this morning, if they ever get here, and we're actually going to start parking them around a site and setting them to go off, and then just letting them record. We'll have battery packs on them. I think that'll work. And we can actually get them in place and then step away, so we're not disturbing the fishes while they're spawning. That would probably be real important with the surgeonfish manta interactions as well, although the mantas will come right up to you. Yes. Literally, they will. It's nice to be able to use these cameras and position them variously around the site to see what's going on. With our big triggerfishes, they're very shy about spawning, right? And also they like to get up early too. So we're going to park them around the triggerfish sites and then move back from them, so we're not in the way. And hopefully we'll be able to get good information that way. And those kinds of cameras are cheap, and so you can get a lot of them and lay them around all over the place. And just have that.
Can you talk to me a little bit about why it's important to have behavior on video? Like, what does the video give you as opposed to just being there and seeing it with your eyes?
Well, it documents things. Case in point, you're doing an interview. If you were just interviewing me for the radio, people would have to imagine what I'm talking about. But you've got the video component, so it helps you to provide elaboration. You can actually documented color changes, because a lot of these fishes actually go through courtship color changes, and these tend to progress as the courtship time approaches, and then naturally when they're done spawning they start to disappear. So having a video or photographic record of that helps us to build a better picture about what we're seeing. And also the other thing is that, again, sometimes divers can interfere with the action, so getting this information, let's say on videotape, or disk drives these days, allows you to get the kinds of data you can't get because you're in the way. Right? There are a variety of reasons why we would do it, really.
All right, I see another really interesting toy there,
Actually,
or instrument.
Yeah, one person's toy is another person's instrument, or vice versa. This is a hydroacoustic, or an acoustic receiver. Some people call them hydrophones. This particular one is made by Vemco in Canada. And what it does is it monitors signals that are put out by little teensy tiny transmitters. Right? This is a tag. This is one of the larger ones we would use for groupers, big groupers, and it is embedded surgically. So we catch the fish, we sedate them, slit them open, stick one of these things in, fill it full of antibacterial everything, sew them up, acclimate them back to happy land, and they go back in the water. And then this thing sends out a signal, a ping, that is detected by this. And each of these tags has its own little number and corresponds with the frequency. And this receiver has a computer inside that says, oh, it's you, number 98. And whenever it swims within a radius that this thing can detect from, it lets us know later who's been visiting this particular site. So what we do with this is we use this to track movements of fishes to a spawning aggregation site. Most of this work we've been doing is with either groupers or with the big Titan triggerfish. And we're slowly building a picture about what their movements are. Okay. And if you lay out an array of this, you can see where they come from what direction, when they come, because it's all, there's a date reference, who they are, and when they turn around and go back after being at the spawning aggregation site. Sure. And it's another neat toy, so to speak.
So that kind of comes back to the discussion that we had about the GPS, and you know, as humans we live on land, and so it's pretty difficult to understand why it's so hard to know what's going on beneath the water, and for example, why the GPS doesn't work underwater, or why you need to use sound in your Vemco receiver there, as opposed to things like radio tags that people have used on birds for a very long time.
Well, some signals don't penetrate the water too easily. All right, GPS signals that come down from the satellite don't go very far into the water column before they essentially dissipate through attenuation or whatever. Water's a pretty good filter for a lot of things. Sound waves, on the other hand, travel really well in water. Now, these tend to be higher frequency than, let's say, that background noise that we're hearing. But you can code information into this, and it can travel reasonably well over a given distance to a detector like this receiver. And as long as there aren't any obstacles in the way, like big coral heads or giant rocks or sunken vessels or something, it's actually a very effective way to be able to gather information. Sound and water go together a lot better than sound and air, for instance. It's a good medium to send sound with. And GPS signals use a different kind of technology, and it doesn't work so well.
So you mentioned that you use these tags with the large triggerfish and the large groupers, but you're unable to use them on the smaller surgeonfish that we were looking at today.
Yeah, that's because you need one about that big. All right, sorry. But this is big and heavy, and if you put this in the body cavity of the surgeonfishes we were looking at, and the surgeonfishes were about, 25 centimeters long, the ones we looked at today, this would cause them serious discomfort, and it'd be very difficult to get any reliable information out of them. You might be pinging something for the next 2 years that's lying on the bottom dead and rotten because this was too much weight for it. There are smaller tags that we'd like to use and we may use, but they have a shorter battery life to them, right? And it's sort of a wait and see attitude. We'll try it, especially with some of the bigger surgeonfishes first, but something this big is just a little too much to be successful with. So. What this does is it's in a waterproof canister. There's a computer on board inside and a sophisticated microphone inside, and they're obviously connected. And the signal goes through this. This plastic is transparent to the signal, right? And it goes right through.
So this guy is sending out sound.
This sends out a signal every so many seconds. It bursts. It says, this is number such and such. It hits the microphone here, and it picks that up, and then sends the signal to the computer, and the computer says, that's number such and such, and it logs it and stores it in flash memory. All right? And then later, we can pop off the top. I'll try to do that, but it's not good, so I guess you can't use that footage. Inside, there's a battery, the computer, and the microphone. All right. We can put sort of a magnetic key in here that allows this thing to start flashing, meaning it wants to download. And I have a little Bluetooth thing that I plug into a laptop computer with the program running, and the information downloads through the Bluetooth into the laptop.
So it downloads wirelessly.
Yeah, I can do it on the boat, but it's splashy out there, so sometimes I just switch out the units. We moor these units underwater. They're usually hanging like this or like this. There's half of one of these buoys to keep them off the bottom. And then periodically we go out, grab them, and replace them, and take them back to the lab, and we download the information, and then we figure out what's been going on. And then the cycle repeats itself. We go back out and replace them and take in new information. So, right now I've got over 40 of them running right now.
Around Palau. I mean,
No, Guam.
around
Yeah.
Guam.
Just mainly from Apra Harbor down as far as Cocos Lagoon, so southwestern Guam primarily, because that's where a lot of the trigger fishing group of work was.